Hi, I'm Ian Learmonth. I'm a final year computing science student at the University of Aberdeen, and this is my introduction to the Linux shell. First off, I'm going to talk about what the shell is. In a Linux system, you don't interact directly with the operating system. Instead, you use a shell. And here I'm going to be using the Bash shell, although there are other shells available. And what I'm talking about here can be applied to other Linux-like operating systems like Mac OS and OpenBSD, FreeBSD, and NetBSD. A shell is a kind of wrapper around operating system functions that you can interact with, and you can change the shell that you're using to change the appearance of your operating system. The main features of the shell are file name expansion, shell and environment variables, the ability to load programs, the ability to redirect input and output, creating scripts, and job control. We'll start off with file name expansion. When entering file names as arguments to commands, that's the parameters after the command that you're passing into the program you're launching, special characters can be used as wildcards, which will be expanded by the shell. So an asterisk will match any number of any character, and a question mark will match any character, but it will only match it once. I've got some examples here. You can see what I've done at the top here is I've run the ls command, which lists the files in the directory, and then I've called the echo command, which outputs everything that was passed in as an argument. And here I've passed it asterisks, but echo doesn't see the asterisks. The shell is actually expanding that asterisk to match all the files in that directory and is passing echo that file list. So you can see the output is the same as ls. I've then passed in file question mark. Now this is only matching one character, so file 1, file 2 and file 3 are matching, but files 4a and 4b are not matching. And then after that I've passed in file question mark A, and you can see there the question mark is matched on 4 and file 4A is shown. Now we're going to talk a bit about shell and environment variables. They're essentially the same thing. The difference is environment variables are global and shell variables are specific to the instance of the shell. The shell could be interactive or it could be running a script. We'll get to scripts later on. You can create environment variables quite easily. You simply give the name and then immediately followed by an equal sign and then the value you wish to assign. And you can also update environment variables in the same way. To make a shell variable an environment variable, you need to export it, and that's very simple as well. To recall the environment variable, simply place a dollar before the variable name, and then just as file name expansion works, your environment variable will be expanded to the value of the variable. So I've got some examples here. I start off by setting the variable named variable to foo, and then using echo, I echo the value of the variable, and you can see there foo has been output. And then to make it an environment variable, I've typed export and then variable. Here you don't put the dollar sign. That will then create the environment variable with the value of the shell variable. To prevent file name expansion and variable replacement, you can actually pass these things as arguments directly by surrounding the argument in single quotes. If you surround it in double quotes, variable replacement will still happen, but file name replacement will not. Loading programs. This is a very important feature of the shell. It's probably the most used feature. To load a program from the shell, simply type the name of the program. You've seen already I've launched the ls command and the echo command. Those are both programs that are loaded by the shell. And the shell finds them by searching my path environment variable. The path environment variable is a list of directories which contains programs, and it will search through them in order until it finds one that matches and then run it. So here I've got some examples. I've echoed the path environment variable, and as you can probably tell, I'm running on a Mac. So you can see here I've got some Python binaries, local binaries, and then user bin, user sbin. These are the system binaries that come with the operating system. And then after that, you can see I've launched the date program, which just outputs the date by simply typing date and pressing enter. Now we'll talk a bit about input and output redirection. When a program is launched, it automatically has the streams opened standard in, standard out, and standard error. That's standard input, standard output, and standard error. Standard input is typically connected to the keyboard. Standard out and standard error are typically connected to the screen, and your terminal will handle that. But using the shell, these can all be redirected. So can redirect outputs and inputs with files, program and a single greater than sign followed by a file name will save the output to a file. Two greater than signs will append to a file. If you only have one, it will overwrite any existing data in the file. And a less than sign will use the contents of the file as the input instead of the keyboard. You can also redirect the output of one program into the input of another program using a pipe. So I've got some examples here. In the first one, I've used the cat program, which takes the input and copies it directly to the output, and redirected the output to a file. So there I've typed hello, this is a file, and that's been saved into the file. And then when I use cat to read from the file and then output, you can see the contents of the file there. Then I've overwritten it with hello, this is another version, and displayed the contents of the file again. And then you can see I've appended and a bit more, and then when I output the contents of the file, you can see the old version plus the extra line. And then I take the output of cat and pipe it into WC, which is the word count program, and you can see there it's counted 3 lines, 9 words and 45 characters. So that's examples of redirecting the input and output. You don't just have to execute commands one at a time. The shell can execute scripts, which are a sequence of commands to be executed one after another. And the shell has built-in functions for if constructs and for and while loops, so you can write pretty complicated programs just using the shell. I've got an example here of a simple script. We'll run through line by line here. The first line, #bang/bin/sh. This tells the shell what to execute with. So when the program is launched, it knows it needs to be run with the shell. We've got an if statement testing whether or not the file exists. It will return true if the file does not exist. and if it doesn't, it will create it, and then it will append the current date to the log, and then tail log will output the last 10 lines of the log. So you could use this if you're recording an event and you've got a log of times and dates that it's occurred. Then running this would add the current time and date and show you the last 9 entries along with the current one that you've just added. Don't worry about the commands here, they will be covered in a later video. I've got an example here of the script running just so you can see. The first time it's run there's 1 date in the log, second time there's 2 dates, third time there's 3 dates, and so on. You can also use the shell to control jobs. When you run programs from the shell, they're run as jobs, and the shell provides the ability to control the way they are run. You can suspend them, have them run in the background, and then bring them back to the foreground. You can also launch jobs to run in the background, which will continue to run even after you've logged out. To suspend a foreground job, simply press Ctrl Z and you will be returned to the shell, and then you can execute commands out the shell as you normally would. And the built-in commands FG and BG, you can foreground a job, which brings it back again, undoing the Ctrl Z, or you can background it, which will allow you to continue to use the shell whilst the job continues to run, and if you log out with a job in the background, it will continue to run. And you can also use the jobs command to view your currently running jobs and also your suspended jobs. So here I've got an example. The command there is using a stream of 0 characters to and then outputting them to a black hole. So it's a simple example of a job that will run to infinity, just for demonstration here. And then by pressing Ctrl Z, I've stopped the job, and you can see there I've returned to the shell. And then running the jobs command, I can see the jobs. There's the job there, it's stopped, it tells me what the job is. And then if I type BG, it places it into the background, continues to run. And then when I run jobs, I can see the job is running. And then typing FG brings it back to the foreground. And then I've pressed Ctrl C there to terminate the job. You can also launch jobs immediately into the background, which I've done here by appending an ampersand to the end of the line as you type it at the shell. And you can see after that what's been given is a job number in square brackets and also a process ID, which will be covered in a later video. And then running the jobs command, I can see the job is running, and bringing it back to the foreground, I've then terminated the job. So that's all for this video. In the next video I'll be looking at the Linux file system with directory hierarchies, file permissions and things like that. Thanks for watching.